This will be our last example in 4.7 part 2. It is another example of composing inverse and regular trig functions together, but in a little bit different format. As you can see here, we have some variables, and we haven't been doing that before. We've been basically just evaluating and finding, square root of 3 over 2, square root of 2 over 2, the familiar ratios with the familiar angles. This is neither of those things, and so what we're going to do is think about using the compositions to actually change this expression into an expression that doesn't involve trig. So one quick thing to notice is that this is a fairly specific process. This will only work if the regular trig function is on the outside. We never reverse this. It just doesn't work that way. There isn't a way to set it up. So this only works if the regular trig function is on the outside. Because what we do is we start with what's on the inside in each of these cases, and we just draw kind of a hypothetical in this case. So I'm going to just start with this sine inverse of x. Now sine, when we think about sine, we think about opposite over hypotenuse, and we're going to do that here, but we don't have anything but x. So I want to just put this x over 1 so we can think about that as being x over 1 as opposite over hypotenuse. Now I'm going to draw kind of a vague triangle over here, and I'm going to make an angle that's just some angle right here. We don't know what it is. The thing that we do know, however, according to this, is that x over 1 is the opposite over the hypotenuse. So I have x and I have 1. We have to figure out what that third side is. We need to know what a is going to be. If we can figure out what that third side is, then we can actually find the cosine of this triangle setup here. So what I'm going to do then is I'm just going to use the Pythagorean theorem to find that. We'll call this a. So a squared plus x squared equals 1 squared. And then we want to get a by itself. So we're going to subtract x squared to the other side. A is equal to 1 minus x squared. Excuse me, a squared is equal to that. So we square root both sides, and then a is going to be equal to the square root of 1 minus x squared. So that is right here. That's what our a side is going to be. Now, just a quick note about a very common mistake people make. Oftentimes people will say, okay, square root of 1 minus x squared, oh, that's just 1 minus x. You can't split this up, actually. This is just going to stay as is. It's just going to stay square root of 1 minus x squared. So we're going to leave it like that. And now think about, what is the cosine of this setup? So what's inside these parentheses basically just means cosine of that thing. So the cosine of that thing is adjacent over hypotenuse. So it's this over 1. So we've got square root of 1 minus x squared over 1, which is just square root of 1 minus x squared. And that is an algebraic expression meaning the same thing as this, but not involving any kind of trig language in there. The second one is very similar. So the second one, we have, again, a triangle to set up with this cosine. We've got 2x. So we're going to make this 2x over 1. Again, we're going to draw a triangle for it. Here's the angle. Cosine is 2x over 1, so that's adjacent over hypotenuse. So that's going to be 2x here, and it's going to be 1 for the hypotenuse right here, assuming that that's the right angle. Then we need to find out what this side is. We'll call it b. And so we do 2x, and make sure you put it in parentheses, squared plus b squared equals 1 squared. We do kind of the same thing as we've done in the past. But we do have to distribute this square to both of those. That's a little piece that a lot of people miss. So that's going to be 4x squared plus b squared equals 1. Subtract the 4x squared. B squared equals 1 minus 4x squared. And then, like before, we are going to square root both sides. So b is equal to the square root of 1 minus 4x squared. So that is this side. Now that we have that, we've got this side determined, we can decide now the cotangent of this triangle setup. And so the cotangent is just going to be adjacent over opposite, so that'll be 2x over square root of 1 minus 4x squared. And I am totally okay if you leave it like that. Now, in a lot of cases, we say that you have to get rid of the square root in the denominator. That's just a complication in this case. That is more work than is necessary, or more work than is reasonable for something like this. Basically, I want you to be able to draw the connection between the compositions and changing it into an algebraic expression rather than a trig expression. So it is okay if you leave it like that, and you guys can expect to see one problem like this on the test coming up, but they're pretty much all just like this. So if you get the triangle set up, then you can, whatever is on the outside, you take that trig function and do that ratio.